Remember the Punnett squares used to sort out possible combinations of alleles and the traits they affect? A pedigree is a diagram that sort of does the opposite. It allows us to see where traits appear in a human family and then figure out the alleles. Let's take as an example the mystery of the trait that skips a generation. What sort of traits can skip a generation? Let's examine this pedigree to see if we can figure it out. First, we need to make sure we understand the symbols in the pedigree. Females are represented by circles, and males by squares. Whether or not a circle or square is shaded tells us which trait is expressed in that individual. In other words, the individual's phenotype. In this pedigree, shading represents brown eyes. A lack of shading indicates blue eyes. Let's see how you do. What does a shaded circle represent? A female with brown eyes. Very good. How about a square without shading? A male with blue eyes. Okay, let's take a look at the trait of eye color as it is expressed in the 3 generations of a family. What can you tell me about the grandparents of this family? Each set of grandparents has a mix of blue and brown eyes. One grandmother and one grandfather have blue eyes, and the other 2 have brown eyes. What about their kids? They all have brown eyes. Aha! The disappearing trait. However, notice that 2 of the grandchildren have blue eyes? Looking at this pedigree, it looks like blue eyes skipped a generation. How can this happen? If we assign genotypes to the individuals, we can start to figure this out. Brown eye coloring is a dominant trait to blue eye coloring. So anyone with blue eyes, we can label little b, or homozygous recessive. If the parents of the 3rd generation have brown eyes but have blue-eyed children, they must be heterozygous. Big B, little b. We know from using a Punnett square that 2 heterozygous parents can produce offspring that are homozygous dominant, heterozygous, and homozygous recessive. With only a few individuals in the pedigree labeled, we can see how the trait of blue eyes was able to skip a generation. The heterozygous parents can be considered carriers of the blue-eyed trait. They don't express the trait, but are able to pass it on to their offspring. Mystery solved.